directions. Basic directions are X, Y and Z. I cap is the direction of x-axis, j cap is the direction of y-axis, and k cap is the direction of z-axis. These are fundamental directions. I cap or j cap, k cap, these are fundamental directions. Or direction of x-axis, y-axis and z-axis respectively. Because these are unit vectors, so magnitude of I cap is equal to magnitude of j cap is equal to magnitude of k cap is equal to 1. Now, if P is a point with x, y and z components, so OP is a vector. Suppose that R is equal to OP vector. It can be written as x, y, z, or x I cap plus y j cap plus z k cap. And magnitude of R, it is equal to the square root of x square plus y square plus z square. For example, R is equal to 1, 2, 3. So magnitude of R, it becomes square root of 1 square plus 2 square plus 3 square equals to the square root of 1 plus 4 plus 9 equals to the square root of 14. Again, if OP is a vector, with P equals to x, y, z, vector OP means vector R. It can be written as magnitude of vector R with its direction like n cap. So direction of n cap is equal to vector R divided by its magnitude. N cap is basically direction of vector R. If it is along x-axis, it becomes I cap. If it is along with y-axis, it becomes j cap. If it is along z-axis, then it becomes k cap. Suppose R is equal to 1, 2, 3, then magnitude of R, it is equal to square root of 1 square plus 2 square plus 3 square. It is equal to square root of 1 plus 4 plus 9. It is equal to square root of 40. Then direction of vector R is equal to vector R divided by its magnitude. Vector R is equal to 1, 2, 3 divided by magnitude of R, it is equal to square root of 40. It is equal to 1 upon square root of 40, comma 2 upon square root of 40, comma 3 upon square root of 40. Or it can be written as 1 upon square root of 40 I cap plus 2 upon square root of 14 j cap plus 3 upon square root of 14 k cap. Now, how we find a vector with the help of two vectors? For example, O is origin, A is a point, B is another point. So we have to find a vector from A to B with the help of vector OA and vector OB. According to head to tail rule, vector AOA plus vector AB is equal to vector OB. So AB vector is equal to OA, OB minus OA. OB means B, OA means A. Because O is origin, its components are 0, 0 and 0. And if we have to find vector B to A with the help of OA and OB, means this vector. We use again triangle law or again head to tail rule. Now OB vector plus BA vector is equal to OA vector. BA vector is equal to OA vector minus OB vector. So BA is equal to A minus B. So simply, if we have to find vector from A to B, it is B minus A, and if we have to find vector from B to A, it is A minus B. Now again come to fundamental directions. I cap, J cap and K cap. You know that if A and B are two vectors, their dot product A dot B is equal to magnitude of A into magnitude of B into cos of theta, where theta is the angle between vectors A and B. And you also know that dot product or scalar product is commutative, means A dot B is equal to B dot A. to apply dot product on fundamental directions. So I dot I, it is equal to magnitude of I into magnitude of I into cos of theta, where theta is the angle between I with itself. So magnitude of I into magnitude of I into cos of 0. So because I is a unit vector, so its magnitude is 1, and cos at 0 degree it is 1. So I dot I is equal to 1. Similarly, j dot j, it is equal to 1. K dot k is equal to 1. Now if we have to find I dot j, it is equal to magnitude of I into magnitude of j into cos of theta. Now theta is the angle between I and j, means the angle between x and y axis, which is 90. So magnitude of I into magnitude of j into cos of 90 degree. Ij are unit vectors, so their magnitudes are 1. Cos at 90 is 0, so I dot j is equal to 0. Similarly, j dot I is equal to 0. Why? Because a dot b is equal to b dot a. Now j dot k, it is also 0, because angle between j and k is 90 and cos 90 is 0. K dot I, it is also equals to 0. K dot j, it is equal to 0. I dot k, it is also equals to 0. Now if vector A is equal to A1, A2, A3, and vector B is equal to B1, B2, B3. A1, A2, A3 are the components of vector A. B1, B2, B3 are the components of vector B. If angle between these vectors is not given, how we find their dot product? Their dot product A dot B is equal to vector A, A1, A2, A3 dot B1, B2, B3 can be written as A1 I cap plus A2 j cap plus A3 k cap dot B1 I cap plus B2 j cap plus B3 k cap. Now A dot B is equal to A1 I cap dot second vector B1 I cap plus B2 j cap plus B3 k cap plus A2 j cap dot B1 I cap plus B2 j cap plus B3 k cap plus A3 k cap dot B1 I cap plus B2 j cap plus B3 k cap. It is equal to A1 b1 into I dot I plus a1 b2 into I dot j plus a1 b3 into I dot k plus a2 b1 j dot I plus a2 b2 into j dot j plus a2 b3 into k into j dot k. a3 b1 k dot I plus a3 b2 k dot j plus a3 b3 k dot k. Now see, I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1, and except these three values, all the remaining dot products are 0. So that's why result will be a1 b1 into 1 plus a2 b2 into 1 plus a3 b3 into 1. So result will be a1 b1 plus a2 b2 plus a3 b3. This is how we find dot product if angle between vectors is not given. For example, vector A is equal to 1, 2, 3 and vector B is equal to 2, minus 1, 5. A dot B is equal to a1 b1 plus a2 b2 plus a3 b3. It is equal to 1 into 2 plus 2 into minus 1 plus 3 into 5. It becomes 2 minus 2 plus 15. The result will be 15 units. Now come to again fundamental directions: x-axis, y-axis, z-axis. I cap is the direction of x-axis, j cap is the direction of y-axis, k cap is the direction of z-axis. You know that A cross B is equal to magnitude of A into magnitude of B into sine of angle between vectors A and B with its direction and cap. And you also know that A cross B is not equals to B cross A. Cartesian product, not Cartesian product, cross product is not commutative, but A cross B is equal to B cross A in opposite direction, means it is equal to minus B cross A. Now we have to apply this formula on fundamental directions. So I cross I is equal to magnitude of I into magnitude of I into sine of theta n cap. Angle between same vectors, it is 0. So magnitude of I into magnitude of I into sine 0. You know that sine 0 is 0. So 0 into any number, it is equal to 0. Similarly, J cross J is equal to 0. K cross K is equal to 0. Now come to I cross J. Now I cross J is equal to magnitude of I into magnitude of J into sine of theta n cap. Now I cap into J cap into sine of angle between I and J. Angle between I and J, it is same as angle between X and Y, which is 90, and sine 90 is equal to 1. 1 multiplied by 1 multiplied by sine 90 is 1, n cap, it is equal to n cap. Now this n cap is the result of I cross J. N cap is unit vector which is perpendicular to I and J both, which must be k cap. So n cap is equal to k cap. As you know that A cross B is equal to minus B cross A, so that J cross I is equal to I cross J in opposite direction, yani minus I cross J means minus K cap. Now come to J cross K. J cross K is equal to magnitude of J into magnitude of K into sine theta n cap. Again, angle between J and K, it is same as angle between Y and Z. So it is equal to 90, and sine 90 is equal to 1. It is equal to 1 into 1 into 1 into n cap. So result is again n cap, but this n cap is unit vector which is perpendicular to J and K both, and a vector which is perpendicular to J and K both, it must be equal to I cap. Now K cross J is equal to minus J cross K, so its result will be minus I cap. Now come to K cross I. K cross I is equal to magnitude of K into magnitude of I into sine theta n cap. Angle between K and I is same as angle between Z axis and X axis, which must be equal to 90. So magnitude of K cap into magnitude of I cap into sine 90. Sine 90 is equal to 1. 1 into 1 into 1 into n cap. So it is equal to n cap. This n cap is unit vector which is perpendicular to k, which is perpendicular to I cap, so it must be equal to j cap. Now because A cross B is equal to minus B cross A, so I cross K is equal to minus j cap. Now, if we are given components of two vectors A and B, A is again A1, A2, A3, and B is equal to B1, B2, B3. We have to find A cross B. A cross B is equal to A1, A2, A3 cross B1, B2, B3. It is equal to A1 I cap plus A2 j cap plus A3 k cap cross B1 I cap plus B2 j cap plus B3 k cap. Now it can be written as A1 I cap cross second vector B1 I cap plus B2 j cap plus B3 k cap plus A2 j cap cross B1 I cap plus B2 j cap plus B3 k cap plus third component A3 k cap cross B1 I cap plus B2 j cap plus B3 k cap. Now it is equal to A1 I cap A1 B1 multiplied by I cross I, and I cross I, it is equal to 0 plus A1 B2 into I cross j, which is equal to k cap plus A1 B3 into I cross k. I cross k is equal to minus j cap plus A2 B1 A2 B1 into j cross I, which is equal to minus k cap plus A2 B2 into j cross j, which is 0 plus A2 B3 into j cross k, which is equal to I cap plus A3 B1 into k cross I. K cross I is equal to j cap plus A3 B2 into k cross j, which is equal to minus I cap plus A3B3 into K cross K, which is 0. Now this part is 0, this part is 0, this part is 0. Now we left only A2B3 I cap minus A3B2 I cap minus A1B3 J cap plus A3B1 J cap. Plus A1B2 K cap minus A2B1 K cap. If we take common, A2B3 minus A3B2 I cap. I cap can be taken common from first two terms. Minus can be taken common with J cap. So we left A1B3 minus A3B1 plus K cap can be taken common. We left A1B2 minus A2B1 can be written as I cap multiplied by a determinant of order 2 by 2 A2 B3 A2 A3 A2 A3 B2 B3 minus J cap into A1 A3 B1 B3 plus K cap into A1 A2 B1 B2, which can be converted into a determinant of order 3 by 3 with first row IJK, with second row A1 A2 A3, with third row B1 B2 B3. We use this determinant of order 3 by 3 for finding cross product of two vectors if angle between vectors is not given.